Hey guys, and welcome to episode 5 of the Object-Oriented NPC series. Like I mentioned in the last episode, in this episode we're going to be working likely on the respawning for the character. So whenever the base NPC dies, you want it to respawn in the same location that it started. And we're also going to set up a function for determining the length of the path that the NPC is currently walking. And the reason we need a specific function for that is because how we're going to do that is going to vary based on whether it's a straight path, in which case we can just use the magnitude property of vector 3's, or if it's using pathfinding, then it would be a lot more complicated because there's going to be multiple paths or multiple straight lines involved in the path, and we want to add all of those up to see the total distance. So getting started, we're going to do the respawning first. So I'm going to go over here to server script servers, server NPCs, and base NPC. Open the BaseNPC module. And so the first thing we're going to do, we're going to add some additional code in the BaseNPC new function. So before we add the NPC and we return the NPC and everything, we're going to find a new section, setting up respawn. And we're going to use the humanoids.died event. And the reason we're going to use that is to detect whenever the NPC dies, and that way we can respawn afterwards. So we're going to define the humanoid first. So local hum, which is of type humanoid, equals char.humanoid. And char in this case is coming from the argument. You could also do npc.character. It refers to the same thing because we said it the same thing. But either way. So then we're going to do humanoid.died connect function. And then before we get any further here, we're going to add one little property to the module. And so we're going to go up here, we're going to call it BaseNPC.RespawnEnabled. And so this will essentially allow you to disable respawning for a specific NPC if you wanted to, right? And we're also going to add BaseNPC.RespawnTime. And so this is going to be the delay after the NPC dies that we want the NPC to respawn. So then back down here in the human.died, we're going to do if NPC.RespawnEnabled then. And the reason we're doing NPC.RespawnEnabled instead of self, because in this context, in the BaseNPC new function, self is going to refer to the module, whichever module you're calling the new function on. So if we're using the aggressive module, which we hadn't, or the aggressive NPC module, which we haven't added yet, then self would refer to the aggressive NPC module. But I'm using NPC here instead of self because, just in case you wanted to specify, by default, all NPCs are going to have respawn enabled set to true. But if you specified in like some other code that created an NPC that you wanted this specific NPC to not respawn, then you could do it on the NPC level as well and change this. So by adding this in here, it just kind of gives you the ability to customize for each individual NPC if you want to. So now we're going to add a delay using the respawn time variable we created. Okay, so in order to actually make it respawn, because I guess just first let's just test this out. So print should respawn. Then I'm going to put a print up here as well. Print NPC died. I'm going to actually move this up here. So now if we run it, and then if we click on the NPC, go to the humanoid, go to properties, and then set the health to 0. And we see NPC died, and then after a couple seconds, it should respawn. So now in order to actually make it respawn, then we're going to have to create a copy of the NPC's model that we can reference in order to clone and then like replace the old one, right? So we're going to go to server storage, we're going to create a new folder. We're going to call this folder the NPC Templates. And then we're going to click on the base NPC, we're going to copy it. So you can either right click, copy, or just Control C. And then NPC Templates, paste into. So now we have this in the NPC Templates. And if you ever change the NPC, make sure you update both the NPC Templates and all the ones that are already out. So now we're going to go up here to the top and just define a private variable. So local templates equals, and we're going to need the server storage, so let me define that. And service, server storage. So then templates f is going to be server storage dot templates or dot NPC templates. So now if we go back down here into this respawn portion, we're going to create a new section, creating new equals sample equals templates f my first child npc.character.name. And so what this is going to do is it's going to search the folder we created, so this folder right here, and then it's going to see if there's any sort of model or anything in there by the name of the same, by the same name of the character. So that's going to find the sample. We're going to specify this as a type model. This is going to be the character model. And we're going to do assert sample no template was found for NPC model npc.character.name. And so this is just kind of a safety check. If you forget to put this in here and you try to have an NPC that can respawn, then it'll give you this error message, just kind of like helping you, just as a reminder, right? And it'll also stop this portion of the code, so it won't move past this. Local clone equals sample clone. So now we're making a copy of this template, right? Sample clone.parent equals workspace clone, and then we're going to use a function called pivot2, and then do npc.origin cframe. So first of all, pivot2 is a function that both models and I believe parts as well have. And the difference between pivot2 and like setting the C-frame, because pivot2 is essentially setting the C-frame of an object, but it does so for like a specific part, it'll do it using the part's pivot, which can be like adjusted. But you can also use it on a model to essentially position a model in a specific location. So if you use pivot2, then provide the C-frame to pivot2, it'll move that model to that position. So that can be useful. So we're using that to position the new NPC to the same location as where we define here origin C-frame equals character get pivot. So this is going to be where the base NPC starts. Then if it dies, it's going to respawn in that same location. And then now we need to remove the old NPC. NPC destroy, npc.character destroy. And so essentially what's going on here, right? We are running the NPC's destroy method, which is way down here, which then runs the self.janitor.destroy, and self.janitor.destroy is the same thing as self.janitor.clean. It literally just runs the clean method. So that'll go back up to here, right? And it'll take this janitor and it'll essentially do all of its chores. So we have a bunch of chores that we added to it throughout, all the code and stuff. So this is going to then clear all those chores. So then we basically clear all the memory, all the loose memory just in this one line for that NPC, and then we destroy the character model itself. And the reason I'm doing these two separately rather than just having the character model be added to the janitor as well, to just do that with the janitor, is in case you wanted to maybe you create a new NPC object and you add it to a specific character, but then you want to remove that NPC object but leave that character model there for some reason. I figured it works to just have the character model and the NPC object kind of be separate entities. But if you wanted, you could also add this in the janitor and just have, and then get rid of this line because it'll just already be run from this part. And then one thing I forgot here, once we create this new model, we want to make sure we create a new NPC object for that new character model. So self:"new clone." So now we're gonna, if you remember this new function, right, it takes a character model. We're going to make a copy of the character model and we're going to put it in the origin location where it originally started. Then we're going to create a new NPC object for that character model, and then we're going to destroy the old character, or the old NPC object, and destroy the old character. So it's pretty simple code, and it works to help you make so an NPC can respawn. And I believe that's pretty much all of the respawn code. So if we run the game, we go over here, humanoid, and if we set health to 0. Cool. Yep, it already works. And if you notice, if the NPC moves a bunch or something, and then the NPC dies over here, notice that it'll respawn where it started because it keeps track of the origin C-frame. And that also accounts for rotation as well. To be honest, I did forget how simplistic the respawn system was, so we will likely also be able to get to getting started with the aggressive NPC in this episode. But next thing we're going to move on to is the calculating the walk distance. We're going to create a new function for that. So we're going to move all the way down to the bottom, right above this destroy method. Calculating walk distance. Function BaseNPC calculate walk distance. And so this is going to return a number. And I'm also going to put a question mark here because there are going to be cases where it won't return the value. In case like an error or something happens. So we're going to define some character variables just to make some things easier. Local character, this is a model, self.character, local root, base part equals character dot humanoid root part. And then we're going to create an if statement that will check if the NPC is either walking in a straight path or if the NPC is walking using pathfinding. So checking current path, if self.current path waypoints, then in this case, so if we remember the current path waypoints, we have this variable or this value, the current path waypoints, and then we have the current destination. And the current path waypoints, whenever the NPC is walking, we set that to the actual waypoints themselves, like a table of waypoints. And whenever the NPC is walking in a straight path, we set the current destination to just the actual vector 3 position that we want the NPC to walk to, right? And so if current path waypoints isn't nil, so you can also just specify isn't nil, but it would run the same, then we know that this is, in fact, NPC is using pathfinding. But then otherwise, else if self.current destination is not a nil, then in this case we know that NPC is walking in a straight path. Then we're going to do one last else, and so this means they're neither using pathfinding or walking in a straight path. So we're just going to add a quick warning: NPC has no current destination or path. And then we're not going to return it. Actually, we'll return 0, in which case we can get rid of this question mark because we know that it will return values, because we're also going to return values here and here. So in the case that they're walking in a straight path, that's going to be the easiest to calculate, right? So we're going to do return self.current destination, since we already know that that's not nil, minus root.position dot magnitude. And I mean, that's pretty straightforward, right? So if you have, this is the NPC and its goal destination is right here, you just get the magnitude of the two vector 3's, and that gives you the distance, or the magnitude of the difference between those two vector 3's, and that gives you the distance between those two positions. So now if we do for the pathfinding portion, calculating total distance, we're going to need to loop through each individual waypoint and then sum up the distances individually using this magnitude property again, but summing them up. So local distance equal to 0, that's what it's going to start off as. Local last position equals, which is going to be a vector 3 equals root.position, so we're going to start with the root's position, and then we're going to do a for loop for I waypoint path waypoint in self.current path waypoints do distance plus equals. So we're going to add to the distance, so it starts at 0, we start at the last pose, which is going to be the root's position, and then we're going to do last pose minus waypoint dot position dot magnitude. And so this is going to take, so it's going to loop through each waypoint, and we're going to say, okay, so for the first waypoint, then it's going to be just in front of the character, right? Just a little bit in front of the character. And so the last pose is currently set to the root's position. Then we get the distance between the last pose and that waypoint. And then we add that to the distance. And then after that, we're going to do last pose equals waypoint dot position. So now, then it's going to set the last pose to this waypoint's position. And then when it runs again, it'll do the next waypoint minus the previous, or minus this waypoint, or minus the previous waypoint, get the distance between those, and add that to the distance. And then it'll just kind of go through this until it gets through all of the waypoints, then totals up the entire distance. Okay, and so to test this, we can use our follow part loop. Testing, so I don't believe we have a part that we can follow. Okay, so we're gonna create a new part. I'm gonna put it in here. Actually, I'll put it right here for now. We're gonna name this part follow part. And then in here, we're gonna do NPC follow part. And we're gonna look at the arguments. Part includes siblings params. Okay, so the part we want to follow is workspace.follow part. That includes siblings. Does that have a default value? I don't think we need that anyway though, because it defaults to false, because if you don't provide it, it'll be nil, which evaluates to false. But we don't need it to be true anyway, so that works. All right, so we're gonna follow part, and then in some sort of for loop or some sort of while loop, we'll do task.spawn function while true do task.wait. I'm gonna do every half a second. Then we're gonna do print NPC calculate walk distance. And so this should tell us the distance that the NPC is walking. And another thing I might actually move this above here. And I'm going to add a slight delay, task.wait for maybe 5 seconds. So now if we run it, we can see it prints 0 because it's not moving anywhere. And then after 5 seconds, it starts moving the part, and we can see it prints the distance to that part. Right now it's just going in a straight path. But then if we move it over here, for example, okay, it doesn't seem like that part's working. So we're going to need to debug that a little bit. The pathfinding portion. Oh, right. It's a simple mistake. So if we go back down here, we need to actually return distance. We got to actually return it. Okay, so it's not moving anywhere. Distance is 0. And then it starts following it. Gets to the part. The distance is pretty much 0. Then we move it over here. And now you can see the distance is a lot further than it actually is if you go on a straight path, because it has to walk all the way around. And notice that if I move it just a tiny little bit over this wall, suddenly the distance skyrockets, right? And so this is the reason this is useful is because say the NPC is chasing a player rather than this part, then we want it to say we want the NPC to lose aggro when the player gets 50 studs away or something, right? Or maybe 100 studs. And so if you're just doing a straight path to calculate that, then even though this NPC has to walk all the way around here just to get to the part, and in total it's walking over 200 studs, right? It'll still count it as being within that maximum distance, and so it'll still keep following the player. But if we use this function instead, then that lets us calculate the actual distance that the NPC will have to walk, which is more accurate. And so this is just kind of a nice utility function we can use. So now that we know that that's working, we can get rid of this testing portion. And then I believe we are completely done with the base NPC, and now we can move on to the aggressive NPC. All right, so let's get started with this aggressive NPC, and this is the fun part, because now that we have all the base utility functions defined, right? So if we do Control-Shift-E, it'll minimize all the functions, so we can kind of see a bit of an array of what we have here, right? So we have all these different functions we can use, and the base NPC itself isn't actually going to use them; it just kind of stores them. And then we can create our aggressive NPC, which will use them in a specific way to create a specific kind of behavior, right? So then to create our aggressive NPC class that will inherit from this class, we're going to go back to this plugin, right? So we're going to go plugins, create module, select the base NPC module right here, create module, and then do inherited class. And so the name is going to be aggressive NPC. This is the name of the module itself. The object name is going to be NPC, and that's just going to be the variable names inside. And then the inherit from is going to be the name of the NPC or the module we want to inherit from. So this module right here. And then the reason we select it is because then it shows if you select different things, it'll show where it's going to insert the module. We want it to be inside of this module. So we're going to create, and now we create a new module, and it has a few lines here. And it's a little bit different than when we did the base class. If we go up here and we do base class, then if we do example object, then we can see it has some extra stuff. It also doesn't have the destroy method because it already inherits that from the base NPC class. But it has this extra set meta table line. And the cool thing about this that makes this really useful. And this is basically how the inheritance works. So we create this new table, right, for this aggressive NPC module. I'm going to get rid of this example because we don't need that. And then, so it creates this new table, and then it adds a meta table to this table with the index meta method. If you're not familiar with meta methods, I do highly recommend looking into them and kind of learning about them. But the index meta method is going to essentially say, if we set this to a table, you can also set it to a function, and it behaves a little bit differently. But if we set it to a table, like the BaseNPC module itself, right, then anytime that we index the aggressive NPC table with a value that isn't defined. So for example, if we did aggressive, pretend this is in a different script or something, right? If we did aggressive NPC dot some key, then if I did print that, so I'm trying to access this key, some key, but it's not defined in the aggressive NPC. And so what it does, if the value of this is nil, is it'll refer to this index meta method, and which will then refer you to the base NPC. And so it'll look somewhere in the base NPC and see if it can find that key in the base NPC instead. And so even though we haven't defined any of these properties in the aggressive NPC, I can still access those properties. So I can do .detect players, and it'll check the aggressive NPC table. It'll see that it doesn't exist in the table, but then it'll check the meta table, or the index meta method, and that'll refer it to here, and it'll see detect players. It'll find this, and it'll see that it's true, right? And so that's a really cool thing about the about meta tables in general, but primarily this specific meta method, and that's what makes this class inheritance possible. So then in this new function, which also uses a colon, then we're gonna create a new NPC by using the base NPC's new function. But notice here I'm using a period to run this function, and the reason for that is if I use a colon here, then I don't want to provide this. And so essentially this is going to create a new base NPC, but it's going to do so with the base NPC module as self. So, all these references to self, those references are going to be to the base NPC module. But then if we do a dot here, then that means we have to specify the base NPC module manually. So this would be the same as what we did before with the colon, right? But we can alternatively specify something else, like the aggressive NPC module, which in this case would be self. And so now we're running this base NPC colon new function, but we're running it using the aggressive NPC module as the self. So now in this case, self refers to aggressive NPC. And so the really cool thing about this is it creates the new NPC object, which is just a table, right? It creates a new empty table, and then it adds the index meta method to that table, referring to self, which in this case is aggressive NPC. And so this NPC object right here that it creates from the BaseNPC.new function, it has a meta table set to the aggressive NPC, and then the aggressive NPC has a meta table set to the base NPC. And so the cool thing about this is if we do, for example, NPC dot, say we wanted to reference maybe one of these values up here, NPC dot respawn time, right? That'll then, so if I just print NPC dot respawn time, that'll then reference the NPC object, which will then check the, it'll go into, if we go into here, we can see that it has the index meta method set to aggressive NPC. And so then this, since respawn time isn't present in the NPC object itself, it'll reference the aggressive NPC, but since it's not present in aggressive NPC, it'll reference the base NPC, which it is present in the base NPC. And so what's cool about that is then if we wanted to override this default value of 3, we could go in here and we could do aggressive NPC.respawn time equals 5. So now when we do NPC.respawn time, it goes to the aggressive NPC and it finds that it's 5, and so then it doesn't go to the base NPC, it already finds the value 5. And so that allows us to essentially have these values be the default for anything in aggressive NPC, but then with the optional ability to override them for this specific kind of NPC. And so now I'm going to get rid of this print statement because we don't need that. Okay, and so now we're going to start off by modifying some of these properties and also adding some additional properties to the aggressive NPC module, like I was mentioning that we can do now, right? So if we do aggressive NPC.NPCID, that's the first thing we want to change, because we notice in here NPCID is base NPC, and this is useful because if we go to the init function, this runs at the start of the game, right? It loops through anything with the NPCID tag, it creates a new NPC for that NPC ID tag. And so essentially we don't even have to redefine this code in Aggressive NPC, because since this is all using colons and it all uses self and stuff, then this is already all set up on Aggressive NPC because it all inherits from the base NPC. And so if all we got to do in order to set this up is change this to a different NPC ID, right? So Aggressive NPC. So that's the new, I misspelled that. That's the new NPC ID we want for this specific kind of NPC. And then now it'll essentially automatically define the Aggressive NPC. So if we do print new, oh, also one thing I forgot. If we go to the base NPC, the new function takes in the character model. We do want to make sure we do take the character model in for this as well, and then pass that through to BaseNPC.new, right? So that way we can make sure the base NPC is getting the character model it needs to. And so then we can do new aggressive NPC, and we're going to do a comma and then the character model. And then in here we can do print new base NPC. And then we're going to do the character model. And so now, since we just have this base NPC, if we run this right now, it'll just be new base NPC, right? And it'll reference that. But then if we make a copy of this, we move it over, we're going to rename it. The name doesn't actually affect anything, but we need to go over here, get rid of this tag, and then add a new tag, Aggressive NPC. Now if I run it, we can see we get new Aggressive NPC, and we get new base NPC, Aggressive NPC. And that's because the Aggressive NPC runs the BaseNPC.new function, which then runs this. So this will print for all of them. And so all of this code will run for every NPC that inherits from BaseNPC. But then this code will only run for Aggressive NPCs, which is very useful, right? And so now I'm just going to get rid of this base NPC because we don't need it anymore. And we're going to get rid of this print statement. So now that we've changed the NPC ID, we know that that works. So then we're going to do aggressive NPC dot all aggressive NPCs is equal to an empty table. And if you remember up here, we had this all NPCs. And so this is going to be all NPCs, including NPCs that inherit from base NPC. And then we want this table to be only aggressive NPCs and things that inherit from aggressive NPC, but not just regular base NPCs, right? So then from that, we're going to do self.allAggressive NPCs character equals NPC. And then NPC.janitor, get chore function, self.allAggressive NPCs. And then set that to nil, and then end. So this is the same thing we did down here, right? Except this time, instead of adding it to the all NPCs table, because it's already in there, right? We already ran the base NPC new function, right? Now we're adding it specifically to the aggressive NPCs table. So now we can individually loop through different types of NPCs if you want to. In range distance, so we're going to change this to 4. Actually, this is going to be a new value. So this is going to be a new value that we're going to use to define how far away a player needs to be from the aggressive NPC in order for the aggressive NPC to essentially be aggroed, to like chase the player and start attacking them, right? So we're going to define that as 4 studs. And this is a value that isn't defined in base NPC, which is perfectly fine because base NPC doesn't rely on aggressive NPC. So aggressive NPC can have all of these values, but can also have additional values separately from that. So then we're also going to set up some other ones. Aggressive NPC.attack cooldown equal to 1 second. So that's going to be the amount of time between individual attacks. Attack damage equal to 5. And so for this system, I'm not going to get too much into like complex combat systems. So for the NPCs attacking, it's just going to be like, if it's within a certain distance, it'll damage you exactly 5, right? So in an actual game, you might want it to be more complicated than that, but that would require like an entirely different tutorial for combat systems. So for now, I'm just going to have a really basic system where every 1 second, if you're within a certain range, then it'll deal damage. And so that's going to be all of the new properties that we're going to add. And so then now we're going to go into the new function. We're going to add some additional code, not very much. We're going to add a new property. So we're going to set properties npc.currentTarget equals nil. And so this is going to be the character model that the NPC is currently chasing, if there is one, right? Then we're also going to start the detection loop. So NPC detection loop function, and then function. So if you guys remember the detection loop from the BaseNPC, this is the function we're calling right here, right? Thanks to the class inheritance. So it's going to take the detected callback, and then the not detected callback, and then an optional params. We're not going to use the params here, but we have this 3 dots. So we have this is going to be the detected callback. So anytime, so we're going to do print enemy is detected, right? And this is going to be the not detected callback, print no enemies detected. I'm going to put this as at least 1 enemy detected. And so this these 3 dots, what these are doing is essentially just takes all the arguments that are passing to these functions, and it just essentially turns it into like a tuple. So if I did like local args equals ... a table of that ... then that takes all of the arguments and it puts it into a table. And all I'm really doing this for is just because I want to redirect these two functions to functions that will define. And so this is just a convenient way to redirect the arguments, which I'll kind of show in a second. But for now, just add these print statements, and we can just see that the detection loop is working. So if you look at here, look how it's all set up, we hit play, it says at least 1 enemy is detected, and we can see it works with our detection loop from last episode, right? Or I think last episode, one of the episodes. And so now we're going to define some actual logic to do when a player is detected. So we're going to create some new functions. We're going to create, so enemies detected, function aggressive NPC, enemies detected, enemies, a table of models, character models to be specific, and then the enemies not detected, function aggressive NPC, enemies not detected. And that won't have any parameters. And so now we can move this into here, move this into here, and then we're going to do self, or I guess NPC, because we're in the new function, so we need to use the NPC rather than self. So then NPC colon enemies detected ... So now we're essentially taking all of these arguments and we're just directly passing them into this function. So then NPC enemies not detected, AI completed it for me, but same idea. So now it'll function the exact same as before, but now we have specific functions defined for them. So we can kind of write the code separately. So then the first thing we're going to do, so whenever an NPC is detected, we're going to define some character variables for the actual NPC object, right, or the NPC's model. So character model self.character local root base part equals char find first child root part. If not root, then return. So we're defining variables for the aggressive NPC's character and the root. And if the root is not there, like if the NPC died or something, then we want to just return and not run this so it doesn't break anything or cause errors. And then we're going to do finding closest enemy. So if this function is running, we already know that there's at least 1 other enemy in sight, right? And so we have a table of all the enemies in sight, and so we want to find whichever one of those enemies is the closest one, right? So we're going to do local enemy model equals nil. Local enemy distance equals nil. I'm going to put that as a number equals nil. And for I, each model, and enemies do. So we're going to loop through all of the enemy character models, and then enemy character variables, local e root equals echar, and first child, humanoid root part. If not e root, then continue end. Local distance, I'm going to define this as a base part. I'm going to define this as a number equals root.position minus e root.position dot magnitude. And so what we're doing here, we're saying, so we're going to loop through all the enemy characters. we're going to find the enemy character for that specific character. We're going to find their root part, and then if they don't have a root part, then we're just going to ignore them and skip to the next one. And if they do, we're going to continue on, and we're going to find the distance between the NPC's position and the enemy character's position. And we're going to check to see if that's less than the current enemy's distance, which is going to start off as nil. So we're going to add some additional stuff. So checking distance. So if the current enemy that we're looking at is equals nil, then or distance is less than enemy distance, then enemy equals echar, enemy distance equals distance. So what we're doing here, the first time we run this, we're going to loop through the first character, right? First enemy character, and enemy is going to be nil. So because we know we haven't looped through any of the characters, we haven't set this to anything yet. So this is already going to go through because it's an or, so it's either one of this, or either this statement, or both. So since the enemy is nil, we can go through and we set the enemy to this enemy character, and we set the distance to that distance that we just calculated. If enemy is not nil, then we know this doesn't pass through, so we're going to go over here instead, and we're going to check this. And so now for the second enemy character that we're looping through, we're going to see, okay, so we have this distance, we're going to compare this distance to the previous distance, and if it's less than the previous distance, then we're going to change these variables to match this new character instead. And so essentially this is going to loop through every character, and it's going to find whichever character has the smallest distance, right? So whichever character is the closest. And then now we're going to set that character as the target. So we're going to do self set as target enemy. And this is a function we haven't defined yet, so I'm going to do that real quick. Setting as target function aggressive NPC set as target. If I can spell hr model. Cool. So this is a new function. We have defined this function, so now we can run this. And then this is the code where we're going to actually set the target, which is going to make the NPC follow that target and do other things, right? So we're going to define the character variables again. Character variables, local char, model equals self.character, local root, base part equals char, find first child, root part, if not root, then return end, local uroot, so the current target that we're setting, right? echar find first child, or we're going to specify that as a base part equals echar first child, humanoid root part, if not eroot, then return end. So then setting target if not already, because this is essentially just running on loop, right? So if the NPC is already chasing that specific character, we don't want to like reset the target because we already have that target set. So we're going to do an if statement. If self.current target does not equal e character, then so if the current target, which is the new property we defined up here, if that's not equal to the character we're trying to set as the target, then we're going to run some extra code. We're going to do self follow part eroot. We're going to do self.current target is equal to echar. Cool. So that's going to be most of the code, but then we're also going to do, actually I'll just start with this for now, so just so we can kind of see how this works. So enemy not detected, we're going to leave this for now, and we're just going to run this, and you can kind of get an idea for how this works, right? So as you can see, we're in the range, and so the NPC is already chasing me. It looks like it's kind of messing up the animations. I'm not sure why that is, but anyway. But then if I were to rotate this guy, make him face the other way so he doesn't see me, then he won't chase me. But then if I get within his range to where he can detect me, then he starts chasing me. And now the animation's working. I think it's when he's close to you that the animation stops working. So I'm not sure why that is. I think it's because he's like starting and stopping over and over. So I'm just going to kind of debug that animation glitch real quick. So let's see. So we're going to get our BaseNPC back. We're going to set this as BaseNPC and go here, because I'm pretty sure it's an issue with this follow part loop. And then we're going to go in BaseNPC. We're going to remove this tag for now, just so this kind of like doesn't follow it too. So we're just going to have this BaseNPC. And then press Control E to expand everything again, and then get rid of this print because I don't need that. And add some testing. Basically the same thing as earlier. So follower NPC follow part. I'm gonna do workspace.follow part, and then I think that's all we're gonna do. So then run follows the part. And we can see it does do that same animation glitch if I like move it slow enough. So I'm gonna see if I can figure out what's going on there. Okay, so I'm not too sure what's going on, but I'm thinking it might be something else. I'm not too sure what it is, but for now, when it's reconfigure the aggressive NPC, so we're gonna add this guy back. We're gonna get rid of this guy. I'm gonna go in the BaseNPC function, go up to new where I made some modifications. We're gonna get rid of this. Select the aggressive NPC. Make sure you add the tag back. And then just double check that it works again. And you can see that it follows me, but you can see it does still have that issue where if it's close enough, it won't play the running animation. So I'm gonna do some more brainstorming, see what I can figure out. Okay, after searching around a lot, I figured out what's going on. So I changed this from my original system to the self.follow distance, but it needs to be a lot smaller of a number. So change this to 0.2. If you want to define a new variable for it, you can, but this is the only place it really appears. This is line 329 in follow part right here, right? So change this to 0.2, and you'll notice now when he's chasing me, if he gets really close, he'll actually like stop and then it'll start again. And that's what's supposed to happen. So now the animation works a lot better. And ignore this. This is a print test I was adding. Get rid of that. So now that we have that out of the way, so we know that the enemies detected works and it sets it as a target. So one thing that is a little bit of a problem is even if you get like as far away as possible. So say I look at this guy, I go over here, and I set him to have a walk speed of like 14 so I can outrun him, right? And so okay, I don't know why his animation went faster. I think that's a bug in the module. But anyway, if I like get far enough away from him, he'll just keep chasing me, which I mean, I'm not even getting far away from him. I'm gonna make his walk speed slower, maybe like 8. So he's chasing me, he's chasing me, he's chasing me. But no matter how far away I get from him, he'll still keep chasing me because it doesn't ever end the follow loop, right? So we want to make sure it ends whenever it gets far enough away. So we're going to go to the Aggressive NPC module. I'm going to minimize everything again in the BaseNPC. In Aggressive NPC, we're going to add a new part, checking distance, local distance equals, let's give me a number, root.position minus root.position magnitude. So if distance is less than or equal to self.inRange distance, then self enemy in range. Okay, so there's a lot of new stuff here. So first of all, I'm going to create a new function, enemy in range function, aggressive NPC enemy in range character model. Cool. So just going to put a print enemy in range. So what we're doing here is so we give the distance between the NPC and whatever the NPC and whatever the NPC is attacking, right? Whoever the NPC is attacking. And then we check if that distance is less than this in range distance. And so if it's less than 4 studs, then we will run this enemy in range function. And this is where we're going to actually trigger the attacking as well. And I'm just realizing that had nothing to do with what I was just saying about being out of range. That's going to be in the enemies not detected part. So I completely said the wrong thing there. But anyway, so this part's going to come in handy when we get the attacking set up. So if we run this, we can kind of see he's chasing me, and I'm not sure why his animation speed's all bugged up, but we see if he gets close enough, it prints enemy in range. And so this is when he would attack me. Okay, so I figured out what was going on with the animation speed. It was a problem in the animate module, like I mentioned. If you want that fixed, it's just a little simple change I made right here. This was set to change the animation to run if it was faster than a certain speed, or walk if it was slower. I should have done it like this instead, but I'm going to re-upload this module, so if anybody's already gotten this module, you can get the updated version that will fix the animation glitch. But anyway, so we're going to get back to this system. So getting back to things, we now have the setAsTarget function working, we have the enemies detected function working, and so now I might just finish up this entire aggressive NPC in this episode. So what we're going to do now is, for one thing, for the enemy in range, if the enemy is in range, I'm just going to directly map that to an attack function. So attack. I'm just going to do self attempt attack each. And this is, yeah, that's supposed to be each. So, and it doesn't seem like, I mean, there's not really a whole lot of point for this specific function. You could just run self attempt attack here if you wanted, but if you wanted to do something else whenever the NPC is in, or whenever the enemy's in range, and then maybe they have like some sort of conditional that leads to whether or not they attempt attack, I'm not sure, but either way. So that's going to do basically the same thing, but now it's just using a different function. So I'm going to up that speed again just because it's kind of goofy. So I'm going to put it back at 16, and so you can see it's printing attack. And you know what? You'll notice it prints every half a second, which is because of the detection loop, but that works. So then for the enemies not detecting function, this is where we're going to check if the enemy is out of range, and then we're going to stop following them, right? Like I was mentioning earlier when I said the completely wrong thing, right? So if not self.current target, then return them. So if no enemies were detected and we're not currently chasing anybody, we don't need to do anything because we're already in the right place, right? So then some character variables, local each model equals self.current target, local enum each find first child humanoid. So this is a humanoid. So we define a couple of variables. So this is the enemy's character, the enemy's humanoid, and then we're going to check the distance that the NPC has to walk in order to reach the character. Local distance number equals self calculate walk distance. So that's the function we made earlier in the episode. So now we're going to check if the distance exists. So if distance is not equal to nil and the distance is greater than self.max detection radius, or not distance, or I guess, or distance equals nil, or ehum equals nil, or ehum self is less than or equal to 0, then we're going to do a bunch of stuff. So this is kind of a lot of different conditions. I'm going to zoom out. So since these are all kind of separated by ORs, so any one of these things separated by ORs can be true and it'll run this. This first one is, actually we can get rid of this part because we already set it up. So if it doesn't have anybody who's chasing, it'll just return 0. So if the distance is greater than the max detection radius, so if we go up here, that's from the BaseNPC, max detection radius is 100 studs. If the distance that the NPC has to walk in order to reach the enemy character is greater than that distance, then we'll run this code, which this code is going to end the chase, which we're going to set that up in a second. Or if the distance is nil, which we won't need to worry about that because I already set that up. I copied that from my old system. So we don't need that part because it won't ever be nil. If we look here in the calculate walk distance, we always return a number. So then if the enemy humanoid is nil, meaning that there wasn't a humanoid found, then we also want to run this because this is going to remove the follow part loop. So it's going to stop following the part, and then it's also going to walk back to the original location. Then also if the enemy character is dead, or their health is less than or equal to 0, then we will also want to run this. So we're going to do ending chase, self remove loop, follow part. And remember this follow part string, it's coming from, if you look at the follow part function right here, it creates a new loop under the name follow part. So we're using that name with the remove loop function to remove that loop, right? So then we're going to do self.current target equals to nil, and then we're going to do returning to original location, self move to origin, or move to, move to location. And this is just going to be using the basic pathfinding, right? Self.origin cframe.position. Cool. And so that should be this function set up. So now the only thing we don't have set up is this attempt attack. But first of all, we're going to test this out. So I'm going to set this guy's walk speed back to like 8. I'm going to run it. He's chasing me. It's really slow. But if I run all the way through here, hopefully I can get out of his range and he'll walk back. Yep, now that I got out of his range, even though from a straight path I want to be 100 steps away, I am from a path of like how he actually has to walk to get to me. And so then he walks away, and I can come back, and he's not like chasing me anymore. One potential issue here is that it also rotates him. So now since he walked back from this side, he's now facing this direction. If that's a problem, you can optionally, you can go ahead and go after this. We could do, I believe this will delay until it finishes. So then we're gonna do char pivot to self origin keyframe, and that should also deal with the rotation issues. So he's chasing me. If I get away from him, and then he'll go back, and hopefully when he arrives, it should re-rotate him back to his original orientation. Oh, okay. Apparently I did the wrong character. I teleported me to that position. I don't want to do that. I want to do self.character. Simple mistake, but big issue. So we're going to try that again. Now he's running away, or not running away, but returning to his original location. And I'm going to hide back here so he doesn't see me. And now you can see it rotated him once you reach the location. Then you can see again, and then if he sees me again, he'll start chasing me again. So we can see that all works, and it's great. Cool. So now the last thing to do, if I up his speed again, another thing, I guess not necessarily the last thing to do, so another thing we need to do, copy this model, paste it in the NPC templates, because otherwise, if we try killing this guy, then he won't respawn, because it doesn't have a template, which I'll actually show you what that looks like. So if you run it, this guy, perchance, by some miraculous chance, happens to die, then it'll give us a warning soon, saying that it doesn't have a template model. So we can fix that by just copying, pasting. Bam, there we go. So now he'll be able to respawn. And so now we'll get to the final part of the aggressive NPC, and that is going to be this attempt attack function. So this is going to be really basic. It's not going to be a complicated combat system. Self.attack, debounce, then return end. So this isn't a property I have defined, but I will define it. NPC.attack debounce equals false. It's just going to be a Boolean property. And so if it's true, then we're going to skip this. We're just not going to run this. And then if we do run this, then attack debounce equals true. Then character variables, eHum equals humanoid equals char times first child humanoid. If eHum is not equal to nil, then eHum take damage self.attack damage. And remember, we defined attack damage all the way up here. And so then essentially we're just finding the enemy character's humanoid, and we're just gonna deal damage directly. This is like a really super simple system, but I'm not getting into complicated combat systems in this video. I may in a future series, we'll see. And I'll probably explain how you can implement it with this system. But for now, I'm just going to leave it simple. So I'm going to do attack cooldown, pass.delay, self.attack cooldown, function, self.attack debounce equal to false. And so all we're doing here, so we set the debounce to true. So that way, if this function tries running while it's currently running already, then we're just going to not do it, right? And then after dealing damage, we're going to run in a separate thread. We're going to do an attack cooldown. And then, so this is going to wait for this amount of time, which is 1 second. And then it's going to set the debounce back to false, so that way this function can run again. And there may be one potential issue with this, but this should work as it is. But it may not always do every second. So once he gets close enough, it'll run that function. You can see it's dealing damage to me. Not very much damage, obviously, but dealing damage. It seems like it's working fine. It's doing every second. Anyway, so this is pretty much the end of this episode. We do have a little bit more for this series. We're going to add different types inheriting from aggressive NPC, just to kind of like show how you can make NPCs attack other NPCs. But this is pretty much the general idea of this series, is to have just modules or classes that inherit from other classes that inherit from other classes, which allows you to have really, really complicated NPCs that can be really cool and do a lot of different things and ways and like inherit functions from one another. But anyway, I've just made 3 of them right here, so you can kind of see that it works even with more than one of them at a time, right? So now I'm being attacked by all 3 of them at the same time. But yeah, anyway, so I hope you enjoyed this video, or thank you for watching. And in the next episode, like I mentioned, we're going to be setting up we're going to set up 2 new subclasses of Aggressive NPC, and those 2 NPCs will essentially fight each other. But then that's probably going to be, next episode's probably going to be the last episode. So thank you for watching this series so far. If you have any questions, definitely join the Discord server in the description below. And then if you want access to their tutorial files, then you can always purchase the $299 a month membership on either YouTube or Patreon, and you'll get access to those for any of my videos and whatnot. And if you want access to tutoring, as always, then you can purchase one of the higher memberships for access to monthly tutoring hours, where I'll help you one-on-one with your projects or anything else you want to learn, right? Either way, thank you for watching, and I hope you enjoyed.